All right, but the word relative frequency should tell you that your answer is going to be a decimal or percent, so know that. And it's asking specifically the relative frequency of students who have cell phones and a curfew. So how many students have cell phones and a curfew? What number on here? 12. Is that going to be my numerator or denominator? All right, it's going to be my numerator because the next part of the sentence says to the total number of students surveyed. So to repeat the whole thing, what's the relative frequency of students who have cell phones and a curfew, which we found out to be 12, to the total number of students surveyed? How many students were surveyed? Good. So then you put that in your calculator and you get a long decimal, which will round appropriately in the next step. It's 0.23, let me put it back in. 0.230769. All right, and then it wants us to round it to the nearest hundredths with a TH. So what is the hundredth spot? Where the 3 is? Anytime that you're rounding, you always look at the number to the right of that number that you're rounding to. So if that number is 0 through 4, then the number that's underlined will stay the same. If it's 5 through 9, then you round up. So is my answer going to be 0.23 or 0.24? 0.23. So I had to go back and give you points if you put it as literally just 0.23, so no 0 in front. I mean, it means the same thing, but still. And then I also gave you points if you wrote it as 23%, but not if you wrote it as 0.231. That would be the thousandths place, not the hundredths place. Or if you did it as 0.24, and then you rounded wrong. All right, so keep that in mind. Questions on this one? Which other one? Okay. Yes, you can go to the restroom. We'll start with 4. I heard a few different numbers, so we'll start with 4. We have 5 companies are rated on their ability to make a part for an aircraft within a certain measurement. The aircraft company decides to hire the company that has the least variation. Keyword there, least variation in the measurement for the part. The company and the box and whisker plot for the measurement of the part is shown in the table below. So company A, B, C, D, E. It says select the company that should be hired. So for box and whisker plots, how do you know if something has a lot of variability or not a lot of variability? What do I look at? The IQR. So if you remember, like box plots are always in this format. All right, the first dot is always your minimum, your last dot is always your maximum. The bars of your box go in the order of Q1, Q2, and Q3. And what's the formula for IQR? Q3 minus Q1. So if I have a long box, that gives you like a visual representation of, I have a big IQR in that example, like here. This would have the most variability because it has the biggest box, right? But this question wants the one with the least variability. So which one would it be? C is the one with the least variability because it's a small box and it looks like the dots are evenly spread out within the box. Yeah, there's like this huge outlier over here potentially, but the smaller box, the smaller IQR tells you that that one has the least variability. Does that make sense? And the C was the correct answer, right? Okay, just make sure. All right, 10 was the other one I heard you guys ask for, so let's look at that one. All right, so for her research project, Barbara wants to investigate if there is a relationship between the age of a basketball player and his free throw shooting. She used the data on 10 students in a linear regression model resulting in this equation. So the equations in this unit, your trend lines, your line of best fit, your linear regression model, whatever you want to call it, are always in the form y equals mx plus b. So even if they're using s's and a's instead of x and y, well, so be it, it's still y equals mx plus b. You don't need to worry about r squareds at all in this unit. They're not that hard to understand, but you don't need it in this unit this year. So the question is, based on this model, what is the residual for the 16-year-old who has the lowest shooting average? What's the formula for residual? Actual minus predicted. Make sure you guys all write that down somewhere on your paper that I'm going to use. Actual minus predicted is the formula for residual. The actual values you get from what? Do you get it from the trend line or from your survey or experiment? Survey. From your survey or experiment is your actual values. It's stuff that you actually witnessed or actually collected. So from your survey or experiment is your actual values. Where do you get your predicted values from? Trend line. From the trend line. So that equation that I highlighted would be your trend line. That's what is just used to predict other things that we didn't necessarily test. So then this specific problem, like here's her data. The age would be my inputs. The shooting average that she has here, is that my actual or my predicted? Actual. Actual. Because as you can see, not everyone scores the exact same thing because of their age. That's from her experiment. The predicted we need to find, and we don't necessarily need to find it for every single input, just for the 16-year-old with the lowest shooting average. So which one are we looking at? The 0.5 or the 0.8? 0.5. The 0.5. So we're really just looking at this part. So we really only need to plug in what into the trend line. What will I plug into the trend line? And where? No, try again. You're close. Well, the 0.5 is my actual value. To find my predicted value for someone who is 16, I plug in 16 into the A. All right, because A is for age, S is for shooting average. We want the predicted value for someone who's 16. Does that make sense? So then you plug that into your calculator, and I already remember the answer from earlier because I've done this in every class today so far. But feel free to verify yourself. It's 0.61 when you plug that in. So my predicted values for the 16-year-old is 0.61, but again, we just want the residual for the one I boxed. So if my residual formula is actual minus predicted, then it's 0.5 minus 0.61, which equals what? Negative 0.11. So that's why the answer was A. So lots about residuals you need to know. You need to know residuals actual minus predicted. You need to know actuals from the actual data that was collected. Predicted is from your trend line. You need to know how to plug stuff in and where if you need to. and then do the actual minus predicted. All right, which other one would you like to see? 6. All right, so this one was actually on your review. So you guys really could have during the test gone back here and looked at the key, and the answer is C. It's the exact same problem. I didn't intend for that to happen, but that's how it was. All right, anyway, I'll show you how to find it because it won't be the exact same on the retake. So it says for the data set below, which statement about outliers is correct? And if you read the statements, it talks about 18 and 70 potentially being outliers. So we'll have to test it. The data is already in numerical order, which is nice. How can I know for sure if something's an outlier or not? So not just like eyeballing it. How can I know for sure? The formulas, where are those formulas? On the board. So they will be there for your retake as well. You feel free to write them in your notes if you want to. So when I'm testing the 18 on whether or not it's an outlier, which of the two formulas do I use? One on the left or the one on the right? One on the left. Because the 18 is smaller than the rest of the data, so you're going to want to see if it's less than Q1 minus 1.5 times the IQR. Because then it will be an outlier if it is. To test the 70, what equation would I use? The one on the right, so the one where it's x greater than Q3 plus 1.5 times the IQR. Because the 70 is greater than the rest of the data. So basically you need to find your Q1 and Q3s, because what's the formula for IQR? Q3 minus Q1, so you need to identify those. Before you can identify your Q3 and Q1, what do you find first? The median of the whole thing, your Q2. So always find that first, because then you can find the median of your lower and upper half. What's my median in this one? 40. That's my Q2. We don't plug that in anywhere. It just separates the data for us. So then for the median of the lower half, never cross out the median, by the way. But you just go left, right, left, right. I have two numbers in the middle. What's the average of 35 and 35? Good. Over here, find the median of your upper half. What's the average of 45 and 50? $45 plus 50 is 95, you're right. And then 95 divided by 2 is 47.5, and that is my Q3. All right, so once you found those, I just showed you how to find them, median of your lower half and upper half, you plug them into your formulas. So I'm going to start with the 18, we're going to test that. So whatever number you're testing will replace the x. Less than Q1, which we said is 35, minus 1.5 times the IQR, which is Q3 minus Q1. So I'm just going to write it in there and let the calculator do it for me. 47.5 minus 35. And then I put that all in my calculator, and you should be able to put that whole thing in Galileo too, with no issues, hopefully. All right, but here's what it should look like in your calculator. All right, and I get 16.25. So is 18 less than 16.25? No. So is it or is it not an outlier? It's not an outlier. When it's not true, it's not an outlier. So 18, it would have to, the number would have to be smaller than 16.25 to be an outlier. So we can cancel out A as an answer and D as an answer because 18 is definitely not an outlier. Make sense? So now testing the 70. So I have 70 greater than Q3, which we said is 47.5, plus 1.5 times the IQR, which again, I'll just write like this, Q3 minus Q1. And when I put that in my calculator, just the right side of the inequality symbol, all right, I get 66.25. Is 70 greater than 66.25? So is it or is it not an outlier? All right, it is an outlier. So then the correct answer is C. 70 is the only outlier, which I know might have thrown you off because when you compare the difference between 65 and 70, it's just 5, right? But when you look more at your data, most of the data is between like 31 and 45. So when you really think about it, 70 is pretty far off from the center of your data. So this algebraically proves it. That's the only way you know for sure. Questions on this one? All right, which other ones? Yes? 11. All right, so another residual one, you will have another residual plot problem on your retake. So here's how you can tackle it. Mrs. Falcon came up with this equation. So another trend line in the form y equals mx plus b, relating the number of absences from class and the chapter test score, and which graph shows the residuals for the data from the table. So again, what's the formula for residuals? Actual minus predicted. And let's look at her data. The absences would be what? Be my inputs. The test scores that are listed here would be what? The actual, that's what her students actually scored. And the predicted we get from what? Plugging it into this given equation. So yeah, I know it's a pain to like plug in all of these inputs and put in all these predicted and find all the residuals. Just do enough to where you can cancel it out and find the right answer. So let's just start with plugging in the 0 for the A. Because A is for absence, T is for test score. So we plugged it into the given equation. What's negative 6 times 0? What's 0 plus 85? So my predicted value for when the input is 0 is 85. I'm going to list that here because there's 3 inputs of 0. Although predicted should be the same for those inputs. So then find your residual. So I'm going to have to add in another row here for residual. What's 95 minus 85? 10. So again, actual minus predicted. What's 80 minus 85? Negative 5. What's 75 minus 85? Negative 10. So the way the residual plots work is your x is always your input and your y is your residual value. So based on what we just figured out for the residuals, I should have 3 different dots for when my input is 0. So we have 3 inputs of 0 and 3 different residuals. Does that make sense? So these points should be graphed on my answer. So let's see if we can eliminate any based off of just those. So does A have 3 different dots on where X is 0? But are they all different? No, you have 2 that are the same. So the answer can't be A. Does B have 3 different dots for an input of 0? No, it just has 1, so it can't be B. Can it be C?
No.
No, again, it just has 1 dot and it should have 3 for an input of 0. Can it be D?
Yes.
Yes. And if you look at what the dots are, they do match what we said they would be. It's 0, 10, 0, -5, and 0, -10. So without even doing these other ones, the other ones would match. I can just do these and have the right answer of B. All right, questions on this one? All right, any other ones? We have time for like one more. Yes? Number 14. All right, so this one, a music band has released 11 videos available for public viewing online. Thousands of people have commented on these videos and many more thousands have viewed them. The relationship between the number of thousands who viewed the video, X, so I always take notes as I go. X is for the number of views. And the number of thousands who have commented on a video is Y. So Y is for comments. And it gives you the equation. It says based on the model, on average, how many views are required in order for a video to gain 3 new comments? So does that 3 go in for the Y or the X?
Y.
It goes in for the Y because it's talking about comments. What do I need? How many views do I need to get 3 new comments? So the X is what we're solving for. So here you can see all I did was plug in the 3 for the Y. And we're solving for X. So instead of adding this decimal, we subtract it on each side. Here's what we get. Instead of multiplying the 0.0003, we divide it on each side. And here's what I get. Now look at what our answer options are. Well, actually, let me ask you something first. Can I have 0.67 of a view? No. So really the minimum number of views I need is 7,759, but that's not an answer option. So go through the answer options. Would 100 views give me 3 new comments? Would 1,000? Would 10,000? Yes. So right here is where the answer becomes greater than what the minimum amount of views we would need. Does that make sense? Okay. I'm going to start checking your sheet for points. If you have a question, feel free to ask.